So, now that you know elimination, if not, just check out that video. You might be wondering what the other algebraic way is. Well, as you might guess from the title of both the video and this slide, it's called substitution. You've heard that word before, haven't you? In the last video, we talked about substituting a value into an equation, namely x equals 1 into the first equation. Without further ado, what is the method of substitution? Using substitution. So say we are given the last example. So that's the last example. Let's label the equations again. Equation 1, equation 2. Is there another approach we can take? Let's try solving for one of the variables in terms of the other. In terms of the other means that we have an equation where one of the variables is isolated on one side, and on the other side of the equation there's the expression made of the other variable and constants. It'll make sense when you see an example. Let's solve for y in equation 1. Follow along. So that's equation 1. 2x plus y equals 10. Let's isolate y by subtracting 2x from both sides. So 2x plus y minus 2x is 10 minus 2x. Since we know that 2x minus x is equal to 0, we get y on the left-hand side. That's good because we wanted only y on the right-hand side, left-hand side. So y equals 10 minus 2x. Is there anything interesting here? We see another y in equation 2. This is just another form of equation 1, so let's just substitute that into equation 2. 5x plus 3 times 10 minus 2x, which is also y, equals 29. So this stuff right here is just y. So 5x plus 3 times y is equal to 29. Let's simplify this equation. We can use the distributive property to multiply out 3 times 10 minus 2x to get 5x plus 30 minus 6x equals 29. Let's combine like terms. 5x minus 6x is just negative x. And then let's subtract 30 from both sides to isolate the negative x. Negative x equals 29 minus 30, which is also equal to negative 1, so x equals 1. Now, since we know that y equals 10 minus 2x, and since x equals 1, y equals 10 minus 2 times 1, which is 8. Therefore, the answer in the ordered pair form x, y is 1, 8. Notice we got the same answer when using substitution as when we used elimination. Generally, so that was a nice example. Let's make this method general so we can apply it to any equation. So, take one of the equations and isolate one of the variables. No coefficients allowed, like 2x and 6y, just x and y. Substitute it into the other equation. So it pretty much just means that we just take whatever that we got from the first step and then substitute it into the other equation. If there are more than 2 equations, we can choose the other equation. Then we can solve for the other variable like we did last time and substitute that variable back into the expression for the other variable. So example would be x equals 1 and y equals 2x minus 5. So 2 times 1 y equals 2 times 1 minus 5. And y equals negative 3. Since x equals 1, so 2 times 1 equals y equals 2 times 1 minus 5, which is 2 times x minus 5. That is not what we got for the last example. So just keep in mind that. Thank you for watching. I will upload something on graphing and no/infinite solutions soon.